All right, guys. Today we will be starting booklet number 12, lesson 1, which is one step equations using mental math. Now, this is a difficult lesson for me to teach because there's no easy way to explain mental math. You're kind of deducting the answer using your logic skills, but I will do my best and we will see how it goes. And then after this lesson, I'm going to create a systematic way for you to solve these problems without just visualizing it mentally. So Unit 12 is all about solving equations, which we do by finding a value for a variable that makes the left-hand side of the equation equal to the right-hand side of the equation. The method we use for determining the value of the variable today is mental math. So what does that mean? This variable right here, x, that is, as we have discussed before, that's a number. We just don't know what that number is. Now, when you have an when you have an equal sign, there is a way to figure out what that number is, right? Because the equal sign tells us that the left-hand side, which is x plus 2, must be the same thing as the right-hand side, which is 5. So it's kind of like a little puzzle, right? You need to find what number you can put inside of the variable x in order to make x plus 2 the same number as 5. Now, in these cases, there's only one right answer. There's only one number that x could be, so let's see if we can figure it out. Now, I'm sure that a lot of students can look at this and say, yep, I understand that if I plug in 3 for x, then this will work. You can visualize that 3 plus 2 is what is going to equal 5. Now, if you struggle to see that, then there are a couple strategies that you can use, right? The first of which being that if you compare both sides, you might be able to piece together that whatever number you are plugging in for x, it needs to be smaller than 5, right? Because when we add 2 to it, it needs to become 5. And that's impossible if x is bigger than 5, because a number that's bigger than 5 plus something is going to be super bigger than 5. We're going in the wrong direction. So we know that x must be less than 5. Now, how much less than 5 is x? Well, you could argue that it's 2 less than 5. But again, if you struggle to make that connections, you can do some guess and check, right? You can maybe plug 2 in for x and say, okay, is it 2 plus 2? Well, no, 2 plus 2 is 4, not 5. That's too small. So let's go up a little bit. Let's go to 3 and let's try that. And that brings me to my next point, which is how to check that your answer is right. Well, in order to check that your answer is right, you simply take your guess, which is x equals 3, and you literally plug that into your equation. Right? 3 plus 2 is equal to 5. And then you calculate the left-hand side, 3 plus 2. And if you've done this correctly, you will eventually get a statement where you have a specific number equaling itself, right? We say that this means the left side is equal to the right side. And if the left side is equal to the right side, then you are correct. The answer was x equals 3. Okay, so let's try the same thing with example 2. Here we have the variable y, and we need to find a very specific value for y so that 2 times this value is equal to 8. Right? Now, again, you can use some logic to help you deduce this answer, right? We know that y needs to be a number smaller than 8 because when we take that number and multiply it by 2, it's going to get bigger, and we want it to be 8, right? So we know that y needs to be some number smaller than 8, and that is arguably enough that we could guess and check our way into the correct answer, right? So if you were really struggling with this, you could say, okay, well, is y 2? Well, not really, because when we have 2 times 2, that doesn't equal 8. 2 times 2 is equal to 4. right? So that's too small. And then you might try 3 and say, well, no, 2 times 3 is equal to 6. And eventually you'll get to the answer of 4. Maybe it'll take you some time. Maybe you can see this right away. But 2 times 4 is going to give us 8. So y must be 4. And let's show that logic in our check section where we say, okay, let's take 2 and multiply that by not y, but 4. We're going to plug in 4 for y, see if this is correct. Is that equal to 8? Yep, 8 is equal to 8. So the left side is equal to the right side, right? This checking statement might seem a little bit trivial, a little bit redundant almost for now, but that is going to be a useful strategy once we get into more complex equations. So try these last couple examples, use mental math to figure out what the variable needs to equal, and then make sure that your answer matches mine and is correct. Now, the first example is a minus 3 is equal to 2. And the answer here is that a is equal to 5, right? We know that a needs to be a number larger than 2 because a minus 3, it's going to get smaller. It's going to get smaller by 3 and then needs to end up as 2. So one might argue that we need to be 3 more than 2, right? So a is 5. And if you want to check that, you can do so by plugging in 5 for a, and 5 minus 3 is, in fact, equal to 2. We get 2 is equal to 2. This next one, b divided by 2 is equal to 3. So we need a number that when we half it is equal to 3. This one's a little bit tricky, but we know that b needs to be bigger than 3, right? Because when we half it, it needs to become 3, and when you have something, it gets smaller. So we need to start off as bigger. Arguably, we need to start off twice as big, because then when you get half as small, you end up as 3. And that is why b is equal to 6. Great. And we can check that. Right, if you plug in 6 for b, divide that by 2, is that equal to 3? Yes, it is. So you say 3 is equal to 3. And in both of these scenarios, we say that left side is equal to right side. Okay. Yeah, that is about it for that lesson. Hopefully it made sense. Like I said, it's a bit difficult for me to explain mental math, but I did my best. So take some time, work on the worksheet, and let me know if you have any questions.